Hi there, welcome back to this channel. Now in this video we're going to be covering the topic of integration. I'll basically be solving questions that are commonly asked in JAM and the kind of questions that you would expect. Alright, so we'll be covering all the forms of questions that you should expect. But if you are new to integration, so I'm going to be starting from the scratch so that you can understand. Now we said integration is basically anti-differentiation. Integration is what? Anti-differentiation. So what that means is that if I reverse the process of differentiation, it means I have integrated. Okay, for example, if I have a function f of x equals x squared over 2, for example. Now, if I asked you to differentiate this, you will say f prime of x is going to be this power will come down. So we have 2 by x, the power reduced by 1. So we have 2 minus 1 all over 2. Okay, so from here we're going to have f prime of x to be equal to 2x, this reduced by 1 and then it's gone, all over 2. 2 takes care of 2. So our f prime of x is going to be what? X. Now if I wanted to reverse this process and get my f of x again, if I want to reverse this process to get f of x again, what I'll do is I'll take the integral. So I'll say take integral of both sides, right? So the way we commonly write it is, or the correct notation is, this f prime of x means dy dx, yeah? Okay, so we can definitely say here that dy dx is equal to x from what we had here, right? So if that's the case, then dy will be equal to x dx. So from here we can integrate. So we are integrating with respect to dx. Is that okay? We call this our integrand. What we are integrating is called our integrand. All right. So by the time we integrate this, we're going to have y. Y will become, by the time we integrate this is what we're going to do. To integrate this guy, you say x, this x, you're going to do the opposite of what you did here. What you did here was to reduce this power by 1. So the first thing here is you increase the power by 1. So the power here was 1, then you add 1 more. Then what you did was to multiply that power by you multiply this power by the term itself. In this case, you will divide by this sets here, 1 plus 1. Use it to divide, which is just the opposite of what you are doing there. So y would become x raised to the power 2 over 2. So you see, we have been able to reverse the process and we have gotten our function back. So that's the whole idea about integration. Use it to get your function back. But now, there are different methods of resolving, of solving differentiation, of solving integration, or different methods of integration. Different methods. I will not be mentioning all the methods, like mentioning their names, but you are going to find the methods I'm going to use very handy. Right. So, for example, if I asked you to integrate 2x, I say find the integral of 2x squared minus 4x plus 1. If you ask to integrate this, you simply come here and draw this integral sign. This is the sign of integral. And then you put dx here. Why? Because you're integrating this term with respect to x. Is that okay? So what you have is this. The integral of this therefore becomes, now, this kind of integral here that we're doing is, there are two types of integral. There are two types of integral. They are the definite integral, and the indefinite integral. So we have definite and indefinite integral. So the definite integral is the one that has boundaries. So there's limits. So there are some integrals that you will see that will come like this. We are saying integrate x plus 2 between 3 and 0, or 0 and 3 rather. This is called the upper limit and this is called the lower limit. Is that okay? So this is definite. This type of integral is definite. But the type I want to start with first are the indefinite integral. In such one, there is no boundary or limit given. So the limits are not given, so we say they are indefinite. Now, one difference between the definite and indefinite is that in the indefinite integral, we must end our into our terms, the answer must be must end with constant of integration. It must be ended with constant of integration. You must always add that constant to what you integrate. So let me show you what I mean here now. So to solve this, we have integrate 2x squared minus 4x plus 1 dx. So how do you integrate this? Just follow the process now. The general term for integration is that if I ask you to integrate x to the n, the formula becomes x raised to power n plus 1, increase that power by 1 and bring the entire 1 plus 1 down. Then plus c, if this case is indefinite, plus c. Now in other videos I will tell you why the c is necessary, but it's very common because I mean it's a very simple idea because the c simply makes room for the possibility of other expressions that may not be captured in your integration. Is that okay? Because you know that the constant always becomes 0 by the time you differentiate. So because of that, when we want to integrate, the constant might be any number. So because of that, we have to add c, which is a constant that might take any form. Is that okay? So that's just the main idea there, but I might prove that in further videos. Now we have this guy to integrate. So we're going to follow just the principle. We have 2x squared here. So we have 2x, that square will be added, 1 will be added to it. Then you bring the entire term down. So that will be 2 plus 1 down here. Add 1 to this and bring the entire term down. Minus 4x, it is raised to power 1 initially, then you add 1 and you bring the entire term down again, 1 plus 1 plus, now 1, this constant term here, by the time you integrate, it becomes a linear term. So you have x was raised to power 0 initially. So you add 1 and then you bring that 0 plus 1 down here. All right, then plus c. So we have 2x raised to power 3 all over 3 minus 4x squared over 2 plus 1 times x raised to power 0. This becomes x. X raised to power 0 plus 1 is x raised to power 1 over 1. Then plus c. Let me go back again. 2x raised to power, this becomes 3 over 3 minus 4x raised to power 2 over 2. Then plus this and plus c. So we have 2x raised to power 3 over 3. This does not change. Minus this here, 2 takes care of this one, and we have 2 here. 2 here 1, 2 here 2. So we have 2x squared plus x plus c. And this becomes our final answer. All right. So with this, we can take on some questions, and you see the way I'm going to resolve them. So we have about 15 questions here. There are 15 questions here that we're going to be solving. Okay. So 15 questions here. There are also trig functions. So I'm going to give you the derivatives, the integrals of trig functions now before we solve them. So we're going to take on the indefinite first. So before we take the trig, let's take this one that is algebraic. Then we'll take this, all the indefinite integrals that are non-trig functions, that have no trig function. So we have number 1 says, that's number 3 in this case. It says find the integral of 1 minus x all over x raised to power 3. So to integrate this, you say you are integrating with respect to x, so you put dx here. Is that okay? So one thing to first do with this is to reduce, unlike differentiation, there is nothing like quotient rule here. Is that okay? So don't make the mistake of using differentiation rather than integration. So here, what you're going to do is this. First, split this into singular fractions. So we have integral of 1 over x cubed minus x over x cubed. Recall that if I wanted to solve this into a single fraction, into one fraction altogether, this is going to be the denominator and the numerator does not change. Is that okay? So here I'm going to have integral of this is inverse of x cubed, that is x raised to the power minus 3, then minus here. We're going to take x here 1 and x here 2. So this becomes 1 over x squared. So by the time you turn this to inverse 2, it becomes x raised to the power minus 2. So in this case, we can go on to integrating them, and then we have x raised to the power minus 3. Don't forget, add 1 to this over minus 3 plus 1. Bring the entire thing down. Minus x, add 1 to this, then bring the entire thing down, so that here we're going to have x raised to the power minus 3 plus 1, that's going to give you minus 2, and you have x raised to the power minus 2 all over here. So one simple thing is that what you have on top as your power is going to be what you have as your denominator. So here you have minus 2 as well. So minus 2, then minus x raised to the power. Here you get a minus 1 over minus 1. So you now have x, let me write this expression here, that will be x raised to the power minus 2 over minus 2 minus x raised to the power minus 1 over minus 1. So in this case, we're going to have, let's bring this minus here, so it becomes minus x raised to the power minus 2 over 2. This minus comes here, so it multiplies this minus, and then it becomes plus. So we have minus times minus plus x raised to the power minus 1 over 1. Is that okay? So over 1. Then here, recall that this means 1 over x squared from what we did here. It was 1 over x squared that transformed into this. So this we can rewrite as 1 over x squared. So minus 1 over x squared dot. Now this whole expression here, this is 1 over 2 times x raised to the power minus 1. You get me? 1 over 2, so it becomes 1 over 2. Is that okay? And if that is not clear, what I'm trying to say is that here, this expression can be written as minus 1 over 2 x raised to the power minus 2 plus x raised to the power minus 1. Is that okay? So this 1 over 2 is what I have here. Then x raised to the power minus 2 has become this. So then plus x raised to the power minus 1 here is going to become what? 1 over x. The same way we reverted this. So here it becomes minus 1 times 1 over 2 times this, 2x squared plus 1 over x. We can now rearrange to put the positive first, so we have 1 over x minus 1 over 2x squared. So far, I've not been adding the constant of integration, so which is a very poor practice. So you must add constant of integration at every step. Add your constant of integration. So here 2 plus c plus c plus c and plus c. So and then this becomes the answer. All right. This becomes the answer. Okay, so let's solve this. So you saw the way I dissolved this fraction. Very simply, I made the denominator, because it's a common denominator, so I split it for both numerators. All right. So here we have integral of 3 over 4x minus 5. So integral of 3 over 4x minus 5 dx. Now, in this case, whenever you have a question like this, what you do is, for most kind of questions that come like this, the method you use is called the U substitution. The method of U substitution is very similar to that of differentiation. Is that okay? So, and in fact, we're going to be applying a little bit of our knowledge of differentiation here. So watch what I'm going to do. The first thing you do is now, this guy is the algebraic term that is complex that we are unable to, simplify. So what we want to do is we want to try and simplify it. But before we go further, now you must know this first, that the integral of 1 over anything with anything which has a power of 1, a linear term under this as a denominator. So what I mean is 1 over x, for example, or 1 over u, or 1 over a, or 1 over whatever you have, that is our integrand. That is, if it's our integrand, you always get ln of that denominator. So ln of the absolute value of that in that denominator plus c. So what that means is that if I am integrating 1 over u du, then with respect to u, so it means that this becomes ln absolute value of u plus c. Now what ln means is the natural log. So it means that this ln u plus c can be written as log to the base exponential u plus c. So it's as simple as this. All right, so to solve this one, you make a u substitution of the denominator. So we say let u, very simply, just follow me. You take u, you make u the denominator. So u becomes 4x minus 5. Now what you want to do is this. Since this denominator will become u, then you want to make this term be with respect to u. So how do you do that? First differentiate this. If you differentiate this, you take du dx, you differentiate u with respect to x. So du dx gives you, by the time you differentiate this, you get 4. Now what you want to do is this, make dx subject of formula. What you just do is this, just follow me. You replace, or they change position basically. You understand? You exchange the position of these guys. Dx comes here, 4 comes here. So you have dx will become 4 will come under du, so we have du over 4. That's the simple way to do it. Is that okay? By the time you cross multiply and do all of those shenanigans, you're going to get the answer. You're going to get exactly this. All right. So here we therefore have that. So since we now have a term for dx, our equation has become 3 over this term we replace by u, so 3 over u dx has become du over 4. Remember dx was here, so we'll put times du over 4. So looking at this term is a numerator, this term is a denominator. We can collect them outside. That becomes 3 over 4. Basically what this term means is that 3 over 1 times 1 over 4. Is that okay? So that will be 3 over 4. So then integral of 1 here, when 3 leaves, becomes 1 that is here. 1 over u du. Does this make sense now? So your idea is to make this term look like this so that you can get something that looks like this. That's the idea. So that we now have 3 over 4. Then integral of 1 over u becomes what? Ln absolute value of u plus c. Is that okay? Our constant of integration, don't forget that. So we have 3 over 4 times ln u. So what is ln u? Now, our u was 4x minus 5. So we'll now bring it back. It becomes absolute value of 4x minus 5 plus c. And this is the answer to the question. All right. Number 13. Number 13 says integral of 5x into bracket 3x squared plus 4 raised to the power 7. Integral of 5x open bracket 3x squared plus 4. Okay. 5x 3x squared plus 4 raised to the power 7 dx. All right, that's correct. So now how do you solve this? With this kind of term, you know you cannot open this bracket because of the size of this power. So you can't open the bracket. What you do is this: make a u substitution for this guy so that you have, let u become 3x squared minus 4. So in that way, it means that your function has become integral of 5x into bracket. This guy is now u, so u to the 7th power dx. Is that okay? But this is not correct because we want to make all the term look like u so that we can differentiate, integrate u with respect to u. Is that okay? So we have to first differentiate here so that we can have a term that is with respect to u. So by the time we differentiate here, we have du dx is equal to this, multiplies this and gives us 6x. So 6x is our, derivative of this guy. So with that, just make the, replacement, exchange. This guy comes here, this guy goes there, so that dx is now on the other side will be equal to du over 6x. So if this is the case, therefore, then we have, if this is the case, then we have that our function has become 5x. Now, don't mind this x, don't worry about it because it is going to, the way it happens is that it's going to cancel out in one way or the other. So we have times, now u raised to power 7, like we had initially, but now dx has now become what? Du over 6x. So we have dot du over 6x. In case you're having problem with the dot, it means times. Is that okay? It means multiplication. So here you are going to see obviously that this guy can take care of this guy. Does that make sense? So what we basically have is what? 5 over 6, because this was over 1, right? 5 over 6, then integral of, because it's a constant, we always bring it out here. We have u raised to the power 7 du, right? So if you now integrate this guy du, it becomes what? Integral of this du becomes 5 over 6 times u raised to the power 7 plus 1 over 7 plus 1. Don't forget that. Then plus c. So we have 5 over 6 multiplied by u to the 8 over 8 plus c. And this becomes 5u to the 8 over 6 by 8. That's 48 plus c. All right. If that's the case, then we have 5u to the 8 over 48. Okay. So 5u to the 8 over 48 plus c. So recall from our initial expression that u was 3x squared minus 4. 3x squared minus 4. And if that's the case, then we therefore have 5 into bracket 3x squared minus 4 to the 8 plus c all over 48. And if this is the case, that's the answer. In fact, that's the answer because there's nothing we can do further here. So that's the answer to that. So you saw the way I made the u substitution. Now the way we make the u substitution is we make the u substitution such that there is usually the most complex term there, we use the most complex term there, but it's made such that one of the term will leave. Is that okay? The other term will leave, especially when you have such terms like this. All right. Another question here that looks like that is, let's take on this one. So we've done this. So let's take on this one. 1 plus e to the x. And we also do this now. Now 1 plus e to the x integral, as number 3, integral of 1 plus e to the x open bracket x plus e to the x plus e to the x over all raised to the power 3 dx. Okay, so you have a term like this. Now, if you look at this question vividly, it's very simple because if you want to make u substitution here, the most advisable one to use is this guy here. Because if you look at this term here, it's going to give us a value by the time we differentiate that can take care of this guy, that can cancel this guy. Is that okay? Let me show you what that means. Let u be equal to this second term, x plus e to the x, and don't bring in the power. Is that okay? So that du dx from here becomes what? Du dx becomes what? Integral of this 1. Is that okay? The integral of, the derivative rather, the derivative of a linear term is a constant. Derivative of linear term is a constant. Why is it linear? The power is 1. Is that okay? In case you're confused. Then plus, if I differentiate this guy, derivative of exponential x is exponential x. It doesn't change. Is that okay? So from here, we'll have that dx is going to be du over 1 plus e raised by x. I hope nobody's confused as per how I made this interchange. I made this to come here, I made this to be the denominator. Is that okay? So that becomes, mathematically it's correct. Is that okay? So that this guy can be, since we have made the u substitution, so that we can have a term with respect to which we are integrating. So we now have our term now becomes integral of 1 plus e to the x, then into bracket, this guy is now u, right? This guy is now u, because that's what we did here, right? Then raised to power 3 dx. If this is the case, then what do we have? You know that, okay, dx, as we've gotten a term for dx here, so we can cancel this and put this instead. So it becomes, our term becomes integral of 1 plus e to the x, and we're writing this u to the third power, then dx, instead of dx, we write du over 1 plus e to the x. Now, if you look at this vividly, it is equal now, or it has looked like the numerator. So this can take care of this. So therefore, we have integral of u to the third du. If that's the case, the integral of u to the third becomes what? U raised to the power 3 plus 1 over 4 over 3 plus 1 plus constant of integration. So this becomes u to the fourth over 4 plus c. Now what is u? You remember that u was x plus e to the x. So u will become what? X plus e to the x all raised to the power 4 over 4 plus c. And that is the answer for this guy. Is that okay? In the exam, this could be written as 1 over 4 x plus e to the x. I hope that is not a problem at all. It shouldn't confuse you. It's the same thing. Is that okay? Now the next one is this. I want to resolve all the questions that do not have integral, that do not have trig first. The ones that don't have trig. All right, so let's do number 10 next. So I have integral of 3x squared plus 4x. So we have integral of 3x squared plus 4x all over x cubed plus 2x squared minus plus 1. x cubed plus 2x squared minus plus 1. Okay. Now you are told to integrate this. Now, if you look at this expression very vividly, if you differentiate this denominator, let's differentiate this denominator first. If I differentiate x cubed plus 2x squared plus 1 dx, what I'll have is, differentiate this, we'll get 3x squared plus 4x plus 0. Okay? And this is exactly what we have in the what? In the numerator. So whenever you have a term like this, a question like this, where the derivative of the denominator is the numerator. I repeat, whenever you have a term where the derivative of the numerator of the denominator is the numerator, or the integral of the denominator is the numerator or is the denominator. Let me repeat that. I said whenever you have a term where the denominator is, or where the numerator is the derivative of the denominator, as in if denominator were to be f of x and numerator were f prime of x, then integral of f prime of x over f of x will always give you ln f of x plus c. Does this make sense now? Ln f of x plus c. That is the idea. Denominator is f of x, numerator is f prime of x. That is the derivative of this guy. Definitely, whenever you have that kind of expression, then the integral of the function becomes ln f of x. Okay, so in this case, therefore, we have integral of 3x squared plus 4x all over x cubed plus 2x squared plus 1 all dx. This will definitely be what? Ln. Integral of this will become what? Ln of the denominator, which is what? X cubed ln x cubed plus 2x squared plus 1 plus c. All right. That is the answer to that. It's as simple and short as that. Okay, now let's go to the functions that have to do with trigonometric, that has trigonometric functions now. Now we also can make trigonometric substitutions, but we rarely see that in JAM, so I will not be treating that here. I'm going to treat it in another class, maybe in the physical class. So we have trigonometric functions now. If I have my function f of x to be a particular term here, any term here, integral of that f of x will be this. If I have my function to be sine x, for example, the integral of that is minus cos x plus c. Don't forget the constant of integration. Is that okay? We call it the arbitrary constant. If my function were cos x, then my integral will be sine x plus c. If the function were I want to remember the ones that we use in differentiation. We have sine x, we have cos x. If my function were sec squared x, and we also use cosec squared x, and we have sec x tan x, and we have cosec x cot x. The idea is this: there will be three negative signs here, so you must remember that there will be three negative signs. The first one will be for the cos x. This guy does not produce a negative sign, so the answer here is going to be sec x tan sec squared x. That's what the integral of sec squared x becomes cot is this guy, so this guy sec squared x first, this one will be sec squared x will become the integral of sec squared x will be tan x. Is that okay? The integral of this one will be minus cot x. Now I'm going to tell you how I'm remembering it. Then the integral of sec x tan x will be sec x, and the integral of cosec x cot x will be cosec minus cosec x. And I told you there must be 3 negatives and 3 positives. 1, 2, 3, 1, 2, 3. All right. So for now, these are the ones you really need. So now how do you remember this? First, know that there is no square here. Is that okay? Nothing here is squared and nothing here appears twice. Nothing here appears twice. This is x. I mean, not even twice. I mean, nothing here. There's no double term here. It's all single term. Cos x, sin x, tan x, cot x, sec x, and cosec x. Unlike here, we have sec x, tan x, cosec x, cot x. Is that okay? So then another thing to remember is this. To use to remember it is this. Remember in differentiation that sin x, cos x, derivative of cos x is minus sin x. So derivative of sin x will now be minus cos x. That's the opposite of that. Then for cos x, the integral of sin x rather will be minus cos x. And the integral of cos x now will now be sin x. Then for sec squared, guys, now, for sec squared x, so you remember sec x tan x, just pick the first one and add, so pick the first one, that will be the sec x. For cosec squared, for cosec x cot x, pick the first one too. And if that's the case, then sec x and tan x are together, so sec squared x will be tan x. That's just how to remember, kind of. And cosec x cot x, cot x and this guy are together, so cosec squared x will give you what? Cot x. Remembering that there is no square here at all. Okay, so let's go into solving questions then. Then you know that, okay, let's still solve the indefinite integrals. Let's solve number 6 here, and then number 14 and number 11. Okay, so number 6 first, 1 over x plus cos x. So we have integral of 1 over x plus cos x dx. Okay, so what do? You simply can split this integral. It becomes integral of 1 over x plus integral of cos x, then plus c, of course. So integral of this is x raised to the power minus 1 plus 1 over, integral of one inverse function. Do you remember this? I told you if you take integral of this, you get ln of that. So it becomes ln x, absolute value of x, plus integral of cos x is what? Sin x. So we have sin x plus c. Let me write that. That is ln x plus sin x plus c. And so that will be the answer. The next question, integral of tan x. Do we have tan x here? Okay, no. So it means we'll be deriving that. So let's solve this one first. Number 14, x cubed integral of x cubed sine x raised to the power 4 dx, x cubed sine x raised to the power 4 dx. Okay, now in order to solve this question, and this question is very simple, but there are 2 ways you can go about it. Let's first try making just u substitution. Let's try making u substitution now. If we make u substitution, that is u will equal to sine x raised to the power 4. Now, the idea is this: whenever you see a question like this, it's best to use integration by parts. But I want to check if u substitution can also resolve it. Integration by parts. You can always use integration by parts. Is that okay? So let u be equal to just this expression alone. this expression here. So that'll be x raised to power 4. So what I'll be doing is I'll be using both methods to solve it, integration by part and this. So u is equal to this guy, then definitely the u dx will be what? 3x to the third, right? Okay. And the reason why I thought to use this is because I knew that this was going to give me x raised to power 3, so to cancel this guy out. But let's not be too hasty to decide. So let's continue. Then we have this guy will come here, this guy will come here. So we have dx will now be equal to what? Du over 3x cubed. So if this is the case, then, and our u is already this, then our integral is integral of x raised to power 3 sine u dx is now du over 3x raised to power 3. Does that make sense? So this can take care of this. So if that makes sense, then this is 1 over 3. So 1 over 3 can be collected outside of the integral sign. And we have sine u du. So this works. All right. So what we have is 1 over 3. Integral of sine u is what? Minus integral of sine u, sine x, minus cos x. So integral of sine u will be what? Times minus cos u plus c. So we bring the minus out here to be minus cos. Now u was what? Was x raised to power 4 from our substitution. So we bring that guy here, x raised to power 4 over 3 plus c. And that becomes the answer. Okay. Now let's try integration by parts to see if it will work. But it should definitely work because integration by parts is used whenever your functions, there are two functions that are not alike. Is that okay? So for example, there are two different functions here. This is the algebraic, this is the trig. This is algebraic, this is trig. Okay? So now, if you want to solve this, there is a trick we use. Now, there's a, or would I say, a mnemonic kind of, to know which one. Now, this is the formula for integration by parts. The formula is integral of u dv is equal to uv minus integral of v du. Very simple. Integral of u dv is equal to uv minus integral of v du. So there are two things we are looking for here. We want to look for the term. You know, this thing looks like this. Is that okay? This is integral, this is integral. One term must be u. One of these terms should be u. The other term should be dv. Is that okay? One of these terms here will be u. The other will be dv. Okay? So if that's the case, one thing we want to do first is this. Let me show you a particular mnemonic we use. We have this LA8. LA8. Now LA8 means L is for logarithmic expressions. Logarithmic expression. We use this term to know which one will be u. We use it to identify which one will be u and which one will be dv. Is that okay? So for example, I said, let me first write what they are. The I stands for inverse trig. So in an expression where you have a logarithmic expression and an inverse trig, your logarithmic expression should be u, the inverse trig should be dv. Is that okay? Then A stands for arithmetic, algebraic expression. And this is an algebraic expression, okay? T stands for trigonometric expression or trig. Remember that they are different, inverse trig and trig. Is that okay? Then E is exponential term. Now, so following this, it means that, this order is the order by which you pick which one will be u and which one will be dv. So this guy coming first, logarithm, always becomes the u if any other term appears with it. Is that okay? So for example, in this our example here, x is over 3. Okay. It follows that basically integration by part can also be used to resolve that question, but I think U substitution has solved it for us, so you don't know to just elongate the visual anyhow. So this is the answer. Is that okay? This. So the next question we're going to solve is this guy. It says ice forms on a refrigerator ice box at the rate of 4 minus 0.6 T. So when you hear rate, it means with respect to T, something with respect to T, right? Per minute after T times. Okay? So it means that the equation is this. If ice forms at a particular rate, it means that the equation becomes m, the mass of ice that's formed. Is that okay? Because we are given in grams here from what I'm seeing. Initially, there are 2 grams of ice. So let's use mass. Mass of ice always forms at the rate of 6, I didn't get that. At the rate of 4 minus 0.6 T. 4 minus 0.6 T grams. Okay? So per minute. So this is with respect to, okay, so the rate is change in m over change in t. Does that make sense? So dm will now become what? 4 minus 0.6 t dt. So if that's the case, then we can get m by integrating both sides. So integral of this gives me m will be equal to integral of 4 minus integral of 0.6 t plus c. So that I have m will be equal to integral of 4 becomes 4 t, because we are differentiating with respect to t. So constant becomes 4 is per t, 4 t rather, minus integral of this becomes 0.6 t squared over 2. Here 1, here 0.3, right? Plus c. So we have m will be equal to 4t minus 0.3t squared plus c. Okay. Question now says, if initially there are 2 grams of ice, find the mass of ice in 5 minutes. Okay? If initially there are 2 grams of ice. So mass of ice m was initially 2 grams. Okay? So find the mass of ice formed in 5 minutes. Okay, since we have been given this thing here, we have been given our m here, and this is the equation that describes m. So we can look for, says the rate is after t minutes. Okay, so 2, our mass is 2 is equal to 4t minus 0.3t squared. Okay, so our equation now becomes, this comes here, let's bring this guy to this side, that becomes 0.3t squared minus 4t plus 2 is equal to 0. So this is our equation here. Okay, so the answer is to find the mass after 5 minutes. Okay, mass after 5 minutes will become 0.3t is now 5. So it is where t is equal to 5 minutes, because it's per minute, so we're not converting to seconds or anything. So that will be 0.3 into bracket 5 squared plus 4 into bracket 5 plus 2. This becomes 0.3 times 25 plus 20 plus 2. This by this gives 7.5. That's 75, 7.5 plus 20 plus 2. So 22 plus this becomes 22. That's 29.5 grams. All right, so that will be the answer. 29.5 grams. Okay, now let's resolve most of the word problems. This one says two variables x and y are such that dy dx is equal to 4x minus 3 and y equals 5. Okay. So find y in terms of x. Okay. It says to find y in terms of x. So two variables x and y are such that dy dx is equal to 4x minus 3. Okay. And y equals 5 when x equals 2. Okay. So from here, we can get, it says to find what? Y in terms of x. So we are going to be deriving an equation here. So at dy dx, dy dx is equal to this guy. Okay. Dy dx is equal to this guy. So dy therefore will become 4x minus 3 all dx. And if that's the case, then we have, if this is the case, then we have that integral of this will give us y. Is that okay? So y will be equal to 4, integral of 4x minus integral of 3 plus c. So y will become integral of 4x is 4x is about 2 over 2 plus minus 3x plus c. This takes care of this and we have 2 here. So y equal to 2x squared minus 3x plus c. So in order to find the constants, we've been given the value of x and y, right? We've been given the value of x and y. So y will now become 5 equal to 2 into bracket x is 2. So 2 squared minus 3 into bracket 2 plus c. So 5 is equal to 2 times 2, 4 times 2, 8 minus 6 plus c. So 5 is equal to 2 plus c, and c becomes 5 minus 2. C equals 3. So if that's the case, our equation was this, so it means that y will be equal to 2x squared minus 3x plus 3. So what it asks us to find is basically the expression. So this is going to be the expression. That's going to be the expression. All right, the next question says, this integral of cos squared theta minus 1 over sine squared theta. So cos squared theta, recall, you have to know the trig identities in order to be able to solve this. Recall that cos squared theta, or just say, you remember that, yes, cos squared theta plus sine squared theta is equal to 1, right? So it means that cos squared theta will be equal to 1 minus sine squared theta, right? If this is the case, then 1 minus, we'll use this guy to replace cos squared theta. So 1 minus sine squared theta minus 1, integral of 1 minus this minus 1 over sine squared theta. So we have integral of 1 minus sine squared theta minus 1. 1 minus 1 cancels out, so we have sine squared theta. Is it definite or indefinite? It's definite. It's a definite integral. So we have between pi and 0. So the difference between definite and indefinite is that you first solve definite like indefinite, then when you get your value, now you will not add c. When you get the expression of the integral, then you will now, substitute some values in this way. So this here, this takes care of this, an integral, we have integral of minus 1 between pi and 0. So what you want to do is this upper limit, you subtract the lower limit from the upper limit. So let's integrate this. So if we integrate minus 1, this is just minus integral of 1. Okay, so if we integrate 1, you are using theta here, so theta is what we are giving here, that's your variable. So it will be, this constant becomes your variable. So it becomes minus theta. Now, between pi and 0, you replace this guy by pi, so minus pi minus 0. So the answer is minus pi. All right. Then the next question, this one also definite integral. We have integral of pi over 4 pi over 12 2 cos 2x dx. 2 cos 0 over 12, yes. 2 cos 2x dx. Okay, so you're told to integrate this. All right, now if you want to integrate this, what you will do is this: you will first integrate this like indefinite, but don't add c since it's definite. So this constant will move out, so it becomes 2 integral of between pi over 4 and pi over 12 of cos 2x. Now if you want to integrate cos 2x, you remember that cos 2x, we can basically say let u be equal to 2x. So if u is 2x, then du dx will be what? 2. So that dx will be equal to du over 2. U substitution is very handy. So 2 integral of 2 pi over 4 pi over 12, or from pi over 12 to pi over 4, we want to find the area under the curve. Is that okay? So cos u, is that okay? Dot du dx to replace all of this. Is that okay? So du over 2 rather, du over 2. Du over 2. So this can basically take care of this because it's multiplication, right? So integral of cos u is what? Sine u. So integral of sine u between pi over 4, pi over 12 and pi over 4. So we now have integral of that. No. So we have been taking the integral of this So we'll now say for pi over 4, we'll have sine 2x, right? Minus pi over 12 sine 2x. So our x now is pi over 4. So we have sine of 2 times pi over 4 minus sine of 2 times pi over 12. Is that okay? Since u is 2x, so that's how we substituted. Here 1, here 2. So sine pi over 2 minus sine here pi over 6, because 2 here 1, 2 here 6. Okay. So this is what we have as our answer. That's what we have as our answer. Okay. So in that case, we have this is our answer. Okay, then there is still one question here. This guy, so we have this question and this question left. This one, this one. It says integral of 2x plus 1 between minus 1 and 1 squared. Integral of 2x plus 1 squared dx between 1 and minus 1. So what we'll do is this. Let's square this. Let's expand this. This squared gives us what? 4x squared plus 2x times 1, 2x times 2, 4x plus square this 1. So that's the simple. If you don't understand how I squared that, just expand it in the way you know how to. What I did is simply square this guy, 4x squared, plus multiply this guy by this guy, 2x plus this. You do it for only squares alone. 2x times 1 has 2x, then times this 2, 4x, plus this one squared, 1. All dx, integral of that between 1 and minus 1. So let's first integrate this. This gives us 4x raised to the power 3 over 3 plus 4x squared over 2 plus 1x or x. Then plus c, but because it is definite, we don't add c. So here 1, here 2. So we now have the upper limit 1, have 4 into bracket 1 cube over 3. Plus this is now 2 squared. That's 2 into bracket 1 squared over nothing, okay? Plus x, which is now 1, minus, for the lower limit, this way we write, you draw a line, then we put minus 1 with the lower limit. With this one, we draw a line, then the upper limit. So we have this guy, 4 into bracket minus 1 cubed over 3 plus 2 into bracket minus 1 squared plus minus 1. This becomes 4 times 1. 1 times 1 raised by 3 is 1, so 4 times 1 is 4 over 3 plus 2 times 1, 2 plus 1, that's 3, minus 1, minus 1 cube is minus 1 times 4, minus 4 over 3 plus 2, 1, minus 1 squared is 1, 2 times 1, 2, minus 1. So here we have 3, 4 over 3 plus 3 over 1 minus 4 over 3, 2 minus 1 is minus 1, so minus 1 over 1. Okay, so what we'll have here is, we take the LCM of this, 3 in 3, 1, times this, 4 plus 1 in 3, 3, times that, 9, minus, LCM of this is 3 also. You see, I'm still putting it in brackets. 3 in 3, 1, then minus 4 minus 3. Okay, so we're going to have this will give us 13 over 3 minus 7 over 3. Minus times minus plus. Exactly. So they have common denominator, that's 3, and 13 plus 7, that's 20. So the answer is 20 over 3. and that will be defined. Okay, there's one more question. Now it says find the area bounded by the curves y equal to that. Y equal to 4 minus x squared. 4 minus x squared and y equal to 2x plus 1. Yes. So now, if you are looking for the area bounded by this curve, one thing we must first find is the point of intersection of both of them, both lines. Is that okay? So at that point, then y1 will go to y2, this second y. Okay, y1 will go to y2. Is that okay? So we now equate them. That's 4 minus x squared. Whenever you see a question like that, I give you two expressions. Just equate them like that. Especially when it tells you to find the equation. What does it say? It says find the area bounded by these curves. This. Okay. 4 minus x squared will be equal to 2x plus 1. Very simply. Bring this guy here so it's a positive. So you have x squared. This guy has come here. Plus 2x. That will come here. Minus 4 plus 1 is equal to 0. So x squared plus 2x minus 3 is equal to 0. And that's the answer. X squared plus 2x minus 3. So that will be it for this video. Do well to subscribe to the channel. In another video, we're going to do more advanced questions. Thank you as you subscribe and share with your friends.